We move on to our last speaker, George Hanna from TwinTech.
Yeah, hello everyone. I'm, as I said, George Hanna from TwinTech. It's amazing that there are still people and so many. So thank you for your patience. I try to stick within the 12 or to 15 minutes once the presentation is ready.
Sorry. Just some logistics. Sorry.
I'll start with the topic. So it's about, let's say, studies we did on a 1 megawatt scale. Don't worry, we're not heading right away there. We don't have the funding yet. And there are many more steps to get there. But we did a lot of work, especially on this topic in more detail. As Thomas nicely said, this could be a fantastic product that could reach very, very large markets. And we had a direct customer proof that it can really reach large markets. So I'll get into that. And I combined this a little with TwinTech's history and approach. You see here the timelines that we have gone through and that we are now, we're at the moment at the very end of this 5 steps that you can see here. And I go through every step and I try to compress that into 12 minutes. So TwinTech actually started by, the urge to make power out of wind, as everyone here. And we checked everything like soft kites, hard kites, 1, 2, 3 tethers, but every time ground focused. And at the very end, we had our energy drone concept. We patented it with a vertical takeoff and landing. And this is how it looks like. So we take off with drone engines. Luckily, the drone industry is exploding. So we can make best use out of that. And we have a ground-based generator. And we actually then made it work. We had 160 plus flights, 18 hours, 2 different types of full proof of concept generations, let's put it that way. Strongly improved aerial efficiency, like the power per square meter that we can achieve from the first to the second one. Also improved the size, and actually with the second system, where's the video? I had a video here where you see it. With the second system, we generated net positive power output through the entire cycle and fully automated, not autonomous yet, but automated. We call it level of automation 2. And that was great. So we originally thought we didn't just scale up our nice, at that time, tricopter concept, where I wanted to show the video, and then start entering the market. And then we did what maybe people should do, like we started talking to the customers. And then the problem started. Our approach is that there airborne wind energy market, and that actually makes me continue working for TwinTech even at harsh times, can address a huge complementary market to the wind turbines market. Like, if we have airborne wind energy, we can produce much more wind power that we urgently need for the energy transition. And we marked out at least 3 different areas. I think this is nothing really new I show you, so I'll be fast. Decentralized on and off-grid markets, hybrid systems with photovoltaics, maybe even as one wind OEM proposed hybrid system, and then floating wind energy. And there are many more additional areas. I will not jump in, but we then talked with customers for the low-hanging fruit decentralized power market to understand what do they need so that they would want to purchase our products. And as you know, and it has been discussed, there is an off-grid and an on-grid commercial, industrial, and public market for this centralized power market. Airborne Wind Europe just did a study with TU Delft that even in Germany there is an 11 gigawatt, maybe even a factor of 10 larger market that is not reachable by wind turbines due to logistic and other reasons. So there's huge markets that are accessible with airborne wind energy only. And we talked to several customers that have gigawatts, one in the on-grid, one in the decentralized off-grid markets, to understand what you need that you purchase our products. And actually, one even paid us nicely to do these studies. They have a lot of off-grid sites. They run 10 gigawatts of diesel gensets and heavy fuel oil generators all over the world, have wind data for more than years that we could use on load demands and everything, and we did calculations together with them. actually used our existing tools at that time, our existing knowledge of bombs, bill of materials to figure out what you need and came up with a solution. The result was a little bit shocking for us. It should be a 1 megawatt system if you really want to address the large markets, shippable in 20 and 40 foot containers, and very clear boundary conditions on the LCE so that even at harsh sites with 10 to 15 cents of diesel power costs, the customers that want to use our systems. Because none of these customers they have would just do it for green power and replace diesel. And we got a very good understanding of the projects, like the cost to set up a project, because they do these projects all the time. Yeah, so then we said, okay, a 1 megawatt system, and we had a below 10 kilowatt system. Wow, is that possible? How can you do this? And we actually started to deep dive into this 1 megawatt system, and we knew that we cannot answer these questions alone. We don't have enough experience. We talked to 4 aviation companies, engineering and also producers. We had a number of Swiss-based universities working intensively with us. We incredibly strongly improved our simulation tool chain from a point mass model that was actually verified by our existing system, so we know the simulations make sense. We included 6 degrees of freedom. We included the 3D models, could at the very end even simulate the flap effect of a 1 megawatt system. How big do they have to be? How strong do the actuators have to be? And we crashed a lot of systems in the simulations until we found solutions. And we pivoted completely our initial VTOL approach and checked many other ways. How can we make a 1 megawatt system work? And finally, we had, thanks to this great cooperation that, by the way, also included the ground station and Imenco, Per, thank you so much for your support. And additional parties there came up with a solution. I just showed you these numbers only shortly. We came up with a CapEx number for initial productions and then a little bit of learning curve. This is not the lowest end, by the way, for a 1 megawatt system. Oops, I move on. I see people taking pictures of this highly secret information. So we really got a very good feeling, it can work, and we have a good understanding of the LCE everything. And the slide you saw before was this case that you sell to an energy supply company that really covers large volumes and still has to sell the electricity. So here is a short, let's say, calculation if you sell the system directly to an end customer. And the economics, if all this happens, are just amazing. Like, it will become a no-brainer to have these products. Also from the LCE, these LCEs are not hot for the utility markets, and this is not the lowest we can get once we have mass production. This is, let's say, the LCEs that you see here are LCEs that can be achieved after 2, 3, 4 years of manufacturing and a little bit of learnings. And very competitive against others. So we fulfilled the requests from customers with this very long and intensive studies. We have a power curve simulated and a nice product concept that at the very end is also nicely mass producible because there is no part larger than 11 meters. Redundancies is there, and it is transportable in 20 and 40 foot containers and can be easily deployed everywhere. We even did a first principle analysis recently on this whole thing, and what is always said, we need 10% of the materials got at least by this analysis verified, roughly. There's maybe not a factor of 10 in the cost because the materials we use will most likely be a little bit more expensive, but still a nice upside if you really break it down to the material cost typical type of first principle analysis. So that is the nice, beautiful output that we got after a bit more than 1 year, or if I'm very honest, longer than 1 year of work. And the good thing is we now know where to get to in order to reach this 1 megawatt. And so we have a very clear goal setting that we have achieved thanks to this very intensive work. But then there was also the big question, how do we get there? And this is not at all easy as well. So finally, also after consultation with experts from aviation, space, and others, we actually came up with a roadmap where we said we will first have a so-called MVP. Maybe it will even become a product in the 20 kilowatt range that has exactly the same type of system architecture that the 1 megawatt system has. Then scale it up to a 150 kilowatt system. Maybe the system later on will be larger, we'll have to see, but this is the current assumptions before we go to the 1 megawatt there. I just keep the 3 megawatt model here because this is our long-term great goal, but we understand how difficult this pathway will be, even to the 1 megawatt. We have to be very honest and humble. And yeah, so why this 20 kilowatt system? I guess everyone would say this is so not interesting for utilities. We have some utilities representatives here. Why do we do this? And the reason is there's not only the scale-up issue, but there's also this topic of reliability, long-term operations, mean time between failures. And I guess if everyone is honest, there's maybe one company now that has longer-term operational experience. Most of us don't have that yet. A few hours of operations. So there's still a long way to go along this x-axis you see here. And we came up with the conclusion that the fastest way to really learn what is required for long-term operation 24/7 is a smaller system that is easy to get flight approvals for, like wingspan below 8 meters, that you can very easily adapt, improve. You start super simple, you allow for crashes, and then you learn, you improve, and you do this long-term operation, and if possible, at the right maturity grade, then maybe even start selling systems and generating revenues there and create trust in that it works. But the cool thing is, with that system, if we create trust, we also have all the learnings for a 1 megawatt system. This is why we approach it. I'm coming slowly to the end. We also actually use the learnings from Makani and Ampex. Some people maybe scaled up so hard, others had maybe too much complexities in the system right from the start and took off a little bit later. So this was also several of the reasons why we've chosen that. So this is our next step, to de-risk and prove performance, safety and regulation, great system to have the discussions with the EASA, what is needed that this can be certified once being extended, scaling, market introduction, but also have proof points so that investors are willing to invest the next steps for the larger systems. Yeah, just a short picture how this maybe also looks like as a product. And yeah, that's it. Thank you very much for your attention.
Thank you very much, George. Okay, we have time for a question.
Just two quick questions. All the power ratings, is this cycle power or
Yes.
peak cycle power?
Electrical and cycle power, yeah.
Okay.
It's not peak power.
And the approximate kilograms per square meter of the intended products?
The kilogram per square meter, I mean the total, for example, for the 1 megawatt system, we expect a weight that is below 3 tons, but at around this number.
And the area?
That is, let me just cross-check that I don't say anything wrong. So 30-meter wingspan, and if I remember that right, it was around 70 to 75 square meters.
Thanks.
Yeah.
Thank you for the vision. I have a question compared to what Reinhard explained yesterday when he told us, that we have to move slow and test first at the scale of what we have today, around the 100 kilowatts. So I see that your vision is on a log scale, where you would go from a 20 kilowatt to 150 kilowatt to 1 megawatt. So how do you reconcile these 2 points of view?
I didn't get the first view again. Please, can you repeat?
The first view was the view that Reinhard presented yesterday,
Yeah.
about testing with what we have today and trying to make a system of about 100 kilowatt viable, and you seem to be shooting very far to 1 megawatt. So
no, I mean, I think this is very much in line with Reinhard, because Reinhard also did the megawatt scaling studies and knows what is needed for larger systems, but that we also need to do a lot of work on small systems and do all the learnings, and in a best case even start generating revenues from small systems. So what you see here as this MVP line, also, like this also includes the learning on small scale, on something that you can adjust easily, actually the same scale that Reinhard was talking about yesterday. So with the larger scale in mind, do all the learnings in a smaller scale, and also learn the market introduction in a small scale. And this is exactly the approach. So I don't see any conflict, but rather same approach here.
Okay,
Thank
thank
you.
you very much. Okay, so we started this round with 100 euros per megawatt hour. We are ending up with 60 euros per megawatt hour.
Or less, yeah.
Yeah,
Hopefully.
maybe we should keep talking. It's getting better and better. But unfortunately, we have to stop. So I believe we have the jury from the poster panels.
Thank you.
Announce the poster winners.